my last lectures, I was talking about the vectors. So we talked vectors are the vector quantities, are those special quantities which have magnitude, direction, and which obeys the laws of vectors. And in laws of vectors, we have talked about addition of vectors, subtraction of vectors, then resolution of a vector. And finally, my students, this time I want to talk about the product of the vectors. So my students, the product of vectors is basically divided into two categories. One famous type of the product of vectors is known as dot product. Yes, dot product. This dot product is also known as scalar product of the vectors. Yeah, scalar product. Dot product of the two vectors is represented by A dot B. We read it as A dot B, which is equal to product of magnitudes of the two vectors. Magnitude of vector A is written as like this. Yeah, this is magnitude of A, magnitude of B, and cosine of the angle between the two vectors, cos of theta. So, it is basically, this is vector A, and if this is vector B, and this is the smaller angle between them. So, we call in case of the dot product or in scalar product, A dot B is equal to product of magnitude of the two vectors and cosine of this smaller angle between the two vectors. So remember students, this dot product is also known as the scalar product. It is a scalar quantity only having its magnitude and no direction. Yeah. So A dot B is equal to AB cos theta, or you can write it like this. Mod of A can be written as A and mod of B without vector at the top. So cos of theta. So A dot B is equal to mod A mod B cos theta. Now, there are some physical quantities which can be written in the form of dot product of the vectors. Before moving to them, those physical quantities, let us talk about geometrical interpretation of this dot product of the vectors. Okay, so we will take a vector, let us call O small a is represents the vector A, and this OB represents vector B, and let theta be the angle between the two vectors. So in order to explain the geometrical meaning of dot product, so we have represented two vectors like this. Now what we will do, we will draw a perpendicular from B. Let us draw BD perpendicular on this vector A, on the vector A. We know A dot B is equal to, yeah, it is AB cos theta. Let us see towards this triangle ODB. In triangle ODB, yes, OD by OB is equal to, yeah, so that is cos of theta. So OD is equal to OB cos theta, yeah. So look here, OB is basically vector B, and what is OD? OD is equal to, yeah, OB is mod of B cos theta. Yeah. Last time we talked about in resolution of a vector, if this is vector B, yeah, vector B, and this is angle theta, so here in this direction there will be one component of this vector B, yeah, known as horizontal component, and that component is equal to B cos theta. So look here, now this OD is equal to B cos theta. So what is B cos theta? It is component of vector B in the direction of vector A. Okay, so we can write A dot B is equal to mod of A. So we will write here magnitude of A. Instead of that, we will write here OA. And then there is B cos theta. This is B cos theta. So instead of B cos theta, we will write here OD. What is OA? It is magnitude of one vector. What is OD? It is the component of second vector. Magnitude of component of second vector in the direction of first vector. So geometrical meaning of dot product is, it is basically product of magnitude of one vector and the magnitude of component of second vector in the direction of first vector. Okay. So similarly, we can represent it in terms of vector B. Vector B and the component of vector A in the direction of vector B. Okay. So there are some special cases which you have to discuss as per the syllabi of 11th class is concerned. One special case is if two vectors are collinear vectors. Collinear vectors. So collinear vectors mein what happens to theta? Yeah, theta is 0 or 180 depending upon whether the vectors are parallel or anti-parallel. So let's talk about their dot product. In that case, we can write A dot B is equal to AB cos of how much? 0. Cos 0 is always equal to 1. So that A dot B is equal to AB. It is product of magnitudes of the two vectors. Yeah. If A is equal to vector B, that is the dot product of two equal vectors is equal to. So under these conditions, it will be equal to mod of A and B mod of A. So that is equal to A square, magnitude of A square, square of its magnitude, dot product in case of this case. Okay, in case of like vectors, the dot product is equal to square of its magnitude. Now, second case is if the two vectors are perpendicular. Yeah, perpendicular means theta equal to 90. So, under this condition, what happens to the dot product? Let's see that. So, A dot B will be equal to A, yeah, mod of A, mod of B, and this is cos of 90. Cos of 90 is always equal to 0. So A dot B is equal to 0. You have to remember this. Whenever two vectors are perpendicular, their dot product is 0. And if we are getting dot product of the two vectors is equal to 0, that means the two vectors are perpendicular. Yeah. So here we can talk about in case of orthogonal unit vectors. So, what are the three unit vectors? Yeah, I, J, and K. What is I dot I equal to? Yeah, I dot I is equal to, it is mod of I, it is mod of I, it is cos of how much? What is angle between I and I along x-axis, second I along x-axis, so it is 0. Magnitude of unit vector is always equal to 1. So this mod of I is also equal to 1 and cos of 0 is equal to 1. So I dot I is equal to 1. So remember always I dot I is equal to J dot J is equal to K dot K is equal to 1. So dot product of these vectors, collinear vectors, unit vectors, yeah, is equal to 1. What about I dot J? I dot J, that is equal to mod of I, yeah, mod of J and cos of 90 because I and J are the unit vectors along x-axis and y-axis. Mod of I is 1, mod of J is 1, cos of 90 is 0, so that is equal to 0. Remember, I dot J is equal to J dot K is equal to K dot I, and these all products are equal to 0. So remember these products because we have to use them while solving the numericals. So we have talked about the special cases in case of dot product of the vectors. Firstly, we talked about dot product. Dot product is also known as a scalar product, and between the two vectors, it is equal to product of magnitude of one vector, magnitude of the second vector, and cosine of the smaller angle between them. Okay. Then we talked about geometrical meaning of the dot product. Geometrical meaning of dot product is basically it is equal to product of magnitude of one vector and the component of the second vector. Yeah, component of magnitude of second vector in the direction of the first vector. That is the geometrical meaning. And finally, what we talked about some of the special cases in case of dot product of the vectors. Now students, you have to remember there are some physical quantities about which you have to talk in your syllabi or in your higher classes which can be written in the form of dot product of the vectors. For example, one famous quantity is work done. Work done is always equal to F dot S. Yeah. And there is instantaneous power. Instantaneous power. And it is always equal to F dot V. And there is one more quantity that is flux, magnetic flux. And it is equal to B dot A. These are the physical quantities which can be written in the form of dot product of the vectors. Whenever there is dot between the two vectors, it represents that the quantity is a scalar quantity. Now, in order to move forward, there is one related question in your syllabus, that is dot product in terms of Cartesian coordinate system. Yeah, rectangular coordinate system. Then we will take here two vectors. Let us take one vector A, which it is components. Yeah, let AX be its component along the x-axis. So I will place here I plus AYJ plus AZK. Similarly, I will take here another vector B, that is equal to BXI plus BYJ plus BZK. Yeah, these are the two vectors. If we have to calculate their dot product, then A dot B will be equal to, simply write down this vector A. So that is AXI plus AYJ plus AZK dot. So BXI plus BYJ plus BZK. Okay. Now what we will do, that is the simple technique. Okay. We'll multiply, it is AX BX. AX BX. Then it is I dot I plus AX BY. I dot J plus AX BZ I dot K plus AY BX J dot I. Similarly, we will write here the products plus so on plus this plus, and finally we will get AZ BZ K dot K. Just now we were talking that I dot I, J dot J and K dot K products are equal to 1. Rest products are equal to 0. So the final answer for this will be AX BX plus AY BY plus AZ BZ, because only these products will qualify, this and this second one and this third one. Other products, because here the two vectors are perpendicular, so their dot will be equal to 0, and this is the answer in case of dot product in case of Cartesian coordinate system. So A dot P is equal to AX BX AY BY AZ BZ. Now these are the questions from the examination point of view. Any question can be asked in your 11th class examination. From the entrance point of view, there are some questions that we have to discuss. Okay. Sometimes we will be given two vectors and we have to calculate their dot product. Sometimes we have to calculate the angle between the two vectors. For example, if vector A is equal to 3i plus 2j plus k. This is one vector. 3, 2 and 1 are its components along x-axis, y-axis and the z-axis. Similarly, B is a vector equal to 2i plus j minus 2k. So if question is, my students, find their dot, so it is very easy. A dot B is equal to, just now we were talking in case of dot product only, I dot I, J dot J and K dot K is qualify. Rest of the products are equal to 0. Yeah, 3 2's are 6, I dot I is 1, 2 1's are 2, minus 2 into 1 minus 2, K dot K is equal to 1. Rest of the products are equal to 0. Yeah, 6 plus 2 minus 2 is equal to 6. So here dot product is equal to 6. Now the second question related to it is, if we have to calculate the angle between the two vectors. For example, these are the two vectors, find the angle between them. So angle can also be found by the help of the same equation. We know A dot B is equal to, yeah, mod A, it is mod B, then there is cos of theta. So we have to find this theta. From this equation we can write cos of theta is equal to A dot B by mod A mod B. Or you can write it like this. Yeah. So in order to calculate this theta, firstly we must be aware about A dot B, then mod of A and mod of B. Yeah. So simply we can calculate here. If this is vector A, mod of A will be equal to, yeah, mod of A will be equal to root of ax square plus ay square plus az. What is ax? That is 3. This is 3 square plus 2 square plus 1 square. That is equal to root of 9 plus 4 plus 1. That is 14. Similarly, mod of B will be equal to root of, yeah, bx square, that is 2 square plus 1 square plus minus 2 whole square. Yeah. So that is equal to root of 4 plus 1 plus 4. That is equal to root of 9. Yeah. So cos theta will be equal to, in this case, cos theta, angle between the two vectors will be equal to A dot B. What is A dot B? That is 6. Exactly. 6 divided by mod of A, mod of B. Mod of A is root of 14. Mod of B is root of 9. And you know root of 9 is 3. So this is 6 by 3 root of 14. So that is equal to 2 by root of 14. Cos theta is equal to this much. By calculating the value, you can find out, or you can write theta is equal to cos inverse, yeah, 2 by root of 14. Yeah. This is the technique by which you can calculate the angle between the two vectors. Or in some cases, the force will be given and displacement will be given. You will be given a question, find the work done. So work done is simply there, F dot S. Okay, we'll be talking about the second product in our second part. Thank you.